Hi everyone. Welcome to Chapter 4, Introduction to Sketching. In this chapter we're going to dive into the very first steps of creating a 3D model in SolidWorks. Think of sketching as the foundation of your design. It's where all the magic begins. On this slide, you can see the topics we'll be covering in this chapter. We'll start with the definition of 2D sketching and then look at the different sketch entities you can use like lines and circles. After that, we will talk about sketch feedback, which is all the helpful information SolidWorks gives you as you draw. Finally, we'll discuss the concept of design intent, and how we use dimensions and sketch relations to make our sketches smart and easy to change later on. By the end of this chapter, students will be able to create fully defined 2D sketches in SolidWorks using appropriate sketch entities, dimensions and geometric relations, apply design intent principles through dimensions and constraints, and follow best practices to ensure stable and adaptable models. So, what exactly is a sketch in SolidWorks? Simply put, a sketch is the starting point for all 3D designs in SolidWorks. It's a 2D drawing made up of basic geometric shapes like lines, circles, and arcs. Think of it as the blueprint for your 3D part. It must be created on a flat surface, which we call a plane or a face. This brings us to the role of sketches in parametric modeling. Your sketch isn't just a static drawing. It's a primary building block for 3D features like extrusions and revolves. By using dimensions and constraints, your sketch controls the geometry of the part. And here's the best part. If you change a dimension in your sketch, the 3D model automatically updates. This is what makes parametric modeling so powerful and flexible. Before we can begin sketching, we first need to create a new part file. To do this, go to the toolbar and click on the New icon. This will open a dialog box where you can choose the type of document you want to create. For our purposes, select Part. A part represents a single design component. It's the fundamental building block in SolidWorks. Later in the course, we'll cover assemblies, which combine multiple parts together, and drawings, which provide detailed 2D documentation. But for now, our focus will be entirely on creating and working with part files. Just like with any other file, it's a good habit to save your work early and often. To save your part, you have a few options. You can simply click the Save icon in the menu bar and choose either Save or Save As. Alternatively, you can go to the File menu and select Save or Save As from the drop-down list. For quicker access, you can also use the keyboard shortcut Ctrl+S. This helps prevent data loss and ensures your progress is always preserved. How to start a sketch. Before you can begin sketching in SolidWorks, you first need to enter sketch mode. You can do this by clicking on the Sketch icon in the Command Manager. This tells SolidWorks you're ready to draw in 2D and it activates all of your sketching tools. The very next step is to select a sketch plane. When you start a new part, you'll see the 3 default planes: front, top, and right. Your choice of plane here is really important because it sets the orientation for your 3D model. So, if you were building a base for a machine, you would likely start on the top plane. Once you've selected a plane, the sketch tools will become active, indicating that you're now in sketch mode. You'll also notice that the sketch button changes to Exit Sketch, confirming that the sketch environment is currently active and ready for you to begin drawing. When you are in an active sketch, you will see a little sketch symbol and a red X at the top right of your screen. This is the confirmation corner, a visual reminder that you are active in a sketch. Clicking the checkmark saves your changes and exits the sketch. Clicking the red X exits the sketch and discards any changes you've made. So, what exactly do we use to create that sketching? The answer lies in the sketch entities. Think of these as your digital pencils and rulers. Sketch entities are the building blocks for all your 2D sketches in SolidWorks. Every 3D feature you create starts here, with a 2D profile made up of one or more of these entities. If you look at the highlighted area on the toolbar, you'll see a range of sketch tools. We have lines, rectangles, circles, arcs, ellipses, polygons, splines, and slots. Each of these has variations. For example, rectangles can be drawn from a corner, from the center, or even as a 3-point rectangle, which lets you define angles as you draw. This table in the middle of the slide lists all the available entities, the button you use to activate them, and a small geometry example. For example, for arcs, you can choose a tangent arc, a center point arc, or a three-point arc, depending on how you want to control it. The same goes for slots. You can create them using a center point, 3 points, or along an arc. At the bottom, you'll also see some special entities like points and centerlines. Points are great for marking specific positions like hole centers, while centerlines are extremely useful for symmetry and reference when applying constraints or dimensions. One tip you'll see in the note here is to use the origin for your first sketch. This is very important for stability and accuracy because it anchors your geometry to a fixed point in the model. Also, make use of snap points when sketching. They help you align geometry precisely without guessing. Next, let's look at one of the most essential tools in sketching, the Smart Dimension tool. In SolidWorks, Smart Dimension is used to define the size and position of sketch entities. It's not just about labeling a measurement. In parametric modeling, this is how we control the geometry of our design. When we apply a dimension, SolidWorks treats it as a driving dimension, meaning it controls the size or location of the geometry. If we change the dimension value, the sketch updates automatically to reflect that change. This is what makes the workflow parametric. As you can see here, there are different types of dimensions that can be applied in a sketch. Linear dimensions are used to measure and control straight distances, which can be horizontal, vertical, or set at any angle. Angular dimensions, on the other hand, define the exact angle between two lines, allowing precise control over the orientation of sketch entities. Both types work together to ensure that the geometry is accurately defined and behaves predictably when modified. The animation here demonstrates how dimensions can be assigned to your sketch. Simply click on the desired entity, drag to position the dimension in a clear location, then type in the exact value and press Enter. Dimensions can be applied either by selecting two straight lines to define the distance between them, or by selecting 2 points to specify the exact spacing. The important thing to remember is, dimensions are the backbone of design intent. By carefully choosing which entities to dimension, we can make sure our design updates intelligently when changes are made. For example, instead of dimensioning every single side of a rectangle, you can set a width and height, and then let geometric relations handle the rest. Now let's talk about a really handy tool when cleaning up your sketches, the Trim Entities tool. Sometimes when you're creating a sketch, you'll end up with extra lines or overlapping geometry that you don't actually need. This is very common when you're drawing shapes that intersect or when you're using construction lines to help with positioning. Instead of redrawing your entire sketch or manually adjusting everything, the Trim Entities tool lets you quickly remove those unwanted parts in just a few clicks. If you look at the left side of the slide, you can see that when you activate Trim Entities, SolidWorks gives you several options. The most popular is Power Trim. Here you simply click and drag your mouse across the parts you want to remove, almost like using an eraser. There's also the Corner Trim option, which trims 2 lines to meet neatly at a corner, and Trim Away Inside or Trim Away Outside, which removes segments based on where you click. Finally, you have Trim to Closest, which trims an entity to the nearest intersection. The example here shows a rectangle intersected by a vertical and horizontal line. With just a quick trim motion, we can remove the upper parts, leaving behind a clean shape without those extra edges. This makes your sketch not only neater but also easier to dimension and modify later. The key takeaway here is, keep your sketches clean and simple. The Trim Entities tool is your go-to option for tidying up and removing anything that doesn't contribute to your final shape. This helps prevent confusion and keeps your design intent clear. Let's move on to another really useful sketch modification tool, the Extend Entities tool. Sometimes when you're creating a sketch, you might find that a line, arc, or spline doesn't quite reach the edge or another geometry where it needs to connect. Instead of redrawing the entity or manually adjusting its endpoints, we can use the Extend Entities tool to quickly lengthen it until it meets another intersecting entity. If you look at the example on the slide, you can see that we have a vertical line that stops short of the horizontal edge. By selecting Extend Entities and clicking on that line, SolidWorks automatically stretches it out until it meets the nearest intersecting geometry. This saves you the trouble of manually dragging the endpoint and trying to align it perfectly. It's worth noting that extend entities works for different types of geometry, not just straight lines but also arcs and splines. So, if you have a curved profile that needs to connect to another shape, you can easily extend it to make that connection. This tool is especially helpful for quickly fixing gaps in your sketches and ensuring that all lines and curves properly connect. And remember, a clean, connected sketch is essential for creating successful 3D features later on. Next, let's take a look at the Offset Entities tool, a very convenient feature for creating parallel copies of your existing sketch geometry. Sometimes in design, you need to create a shape that is exactly the same as another, but offset inwards or outwards by a specific distance. For example, you might want to make a smaller inner profile or a larger outer boundary for a part. Instead of manually redrawing the shape, the Offset Entities tool does it instantly, keeping everything perfectly parallel. If you look at the example here, the first sketch is our original circle. Using the Offset Entities command, SolidWorks creates a second sketch, which is a perfect copy positioned at a distance we specify. This distance can be positive to offset outward or negative to offset inward. The yellow outline you see here represents the offset copy generated from the original sketch. This tool works not only with circles but also with any sketch geometry, lines, arcs, splines, or even complex closed shapes. And if you have multiple entities selected, the offset will maintain their original relationships, ensuring everything stays consistent. It's especially useful for tasks like defining wall thickness for hollow parts, creating grooves, or setting clearance gaps in assemblies. The best part is that it's quick, precise, and fully parametric, so if you adjust the offset distance later, your model updates automatically. Let's move on to a tool that can save you a lot of time and ensure accuracy, the Convert Entities tool. The main purpose of Convert Entities is to take existing geometry, such as edges, faces, or curves, and copy it directly into your current sketch. This is extremely useful when you need to reference parts of your model without manually redrawing them. Looking at the example here, we start with the original part. Then we create a new sketch plane above the part. Normally, if we wanted to recreate the top profile of that part, we'd have to manually sketch the shape again, but that takes time and risks introducing errors. Instead, with Convert Entities, we simply select the edges we want to copy, and SolidWorks projects them directly onto our new sketch plane. The result is shown on the right, a loop of edges projected exactly as they appear on the original part, now part of our active sketch. From here, we can use this copied geometry to create new features such as extrusions, cuts, or offsets, without worrying about inaccuracies. This is not only faster but also ensures that your new geometry is always linked to the original. So if the original part changes, your converted sketch will update automatically. That's how Convert Entities helps maintain design intent while streamlining your workflow. Here we have the Mirror Entities tool, one of the quickest ways to create symmetrical sketches in SolidWorks. Instead of manually drawing both sides of a symmetrical shape and trying to make them identical, we can draw only one side and let SolidWorks do the rest. The Mirror Entities tool takes the geometry you've drawn and creates an exact mirrored copy across a center line or any straight reference line. If you look at the example here, on the left we've drawn just one side of a heart shape. We also have a vertical center line running through the middle. This acts as our mirror line. When we select the original curve and the center line, then apply Mirror Entities, SolidWorks automatically generates the opposite side, perfectly matching the original. What's great about this method is that the mirrored side is fully linked to the original geometry. If you change the original side, for example adjusting the curve or dimensions, the mirrored side updates automatically. This ensures both sides always stay identical without extra work. This tool is especially useful for parts like brackets, levers, symmetrical profiles, or any design where accuracy and balance between two halves are important. It's a huge time saver and helps maintain clean, consistent sketches. Now let's talk about the Sketch Pattern Entities tools, which are huge time savers when you need to create repeated geometry in your sketches. Instead of drawing the same shapes over and over, you can use these tools to duplicate them automatically with perfect precision. In SolidWorks, we have two main types of sketch patterns: linear sketch pattern and circular sketch pattern. The linear sketch pattern is used when you want to copy your sketch entities in rows and columns. You can control the distance between each copy, both horizontally and vertically, and specify how many instances you want in each direction. This is perfect for things like creating evenly spaced holes on a plate or repeated features along a straight path. The circular sketch pattern, on the other hand, is used to arrange copies of your sketch entities in a circle around a center point or an axis. You decide how many instances you want and the total angle over which they are spread. This is ideal for designs like bolt hole circles, fan blades, or any radial arrangement. The beauty of using these pattern tools is that everything remains parametric. If you change the original entity or adjust the spacing or number of instances, SolidWorks updates the entire pattern automatically. This saves you a lot of time and ensures all copies remain perfectly consistent. Now that we've looked at the basics of sketch patterns, let's dive a little deeper into the two main types, linear sketch pattern and circular sketch pattern, and see them in action. First, we have the linear sketch pattern. This tool lets us create multiple copies of our sketch entities arranged in rows and columns. You can see here in the example that we start with just a single circle in the top left corner of the rectangle. Using the linear sketch pattern settings, we define the direction. In this case, the x-axis for horizontal and the y-axis for vertical, and then set the spacing between each copy. We also decide how many instances we want in each direction. Once applied, SolidWorks duplicates the circle in a neat grid pattern across the entire area. This is incredibly useful for things like hole arrays or repeated features on flat plates. Next, we have the circular sketch pattern. This works similarly but arranges copies in a circular layout around a center point or axis. In the example here, we start with just one hole positioned along the edge of a circle. We select that hole, choose the center point, and specify the number of instances and the total rotation angle. SolidWorks then creates evenly spaced copies all the way around. This is perfect for parts like flanges, gears, or anything with evenly spaced features in a circular arrangement. Now let's take a look at the display/delete relations tool, a really important feature when it comes to managing your sketch constraints. As you know, geometric relations like vertical, horizontal, coincident, equal, tangent, and so on control how your sketch geometry behaves. These relations are a big part of maintaining design intent, but sometimes they can cause issues. For example, when a sketch becomes overdefined or behaves in an unexpected way. This is where display/delete relations comes in. When you open this tool, SolidWorks lists all the geometric relations currently applied in the active sketch. In the example here, you can see a list of vertical, collinear, tangent, and coincident relations on the left-hand panel. Each relation shows which entities it's applied to, so you can easily understand how the geometry is being controlled. From here, you can select a relation to highlight it in the graphics area, delete a specific one that's causing a problem, or even delete all relations if you want to start fresh. You can also see whether the relations are satisfied or if they're suppressed. This tool is incredibly useful for troubleshooting your sketches. If something isn't behaving as you expect, checking your relations here can quickly reveal if there's a conflict or an unnecessary constraint. The goal is always to keep only the relations that help maintain your design intent, and remove any that get in the way. Let's now talk about something that happens constantly while you're sketching in SolidWorks, but you might not even realize how powerful it is: sketch feedback. Sketch feedback refers to the visual and interactive cues SolidWorks provides as you create or edit your sketches. These cues tell you in real time the status, constraints, and relationships of your sketch entities. For example, you might see little icons showing that a line is horizontal, that 2 points are coincident, or that a circle is fully defined. This feedback is there to guide you so you can make sure your sketch is behaving exactly as you intended. Why does this matter? Well, first of all, it ensures accuracy during sketch creation. You're not just guessing, you're getting confirmation that your constraints and dimensions are correctly applied. It also helps maintain design intent because you can instantly see whether your intended relationships between entities are in place. Another big advantage is that it reduces errors before you even move on to creating 3D features. If something is wrong in the 2D sketch, you can spot and fix it immediately, saving a lot of time later. And finally, sketch feedback speeds up your workflow by giving you immediate visual validation, so you don't have to constantly stop and check manually. In short, sketch feedback is like your personal quality checker, constantly watching over your shoulder and keeping your sketches precise, logical, and ready for 3D modeling. Let's start exploring the different elements of sketch feedback, beginning with inference lines and snaps. When you're sketching in SolidWorks, the software actively guides you by showing inference lines. These are dashed lines that appear to help you align new entities with the origin, existing points, or other geometry in your sketch. Think of them as visual alignment guides that keep everything neatly positioned without guesswork. Alongside inference lines, SolidWorks also provides snap points, which are small visual cues that appear when your cursor hovers over important positions like the midpoint, endpoint, or center of another entity. These snaps ensure you connect or align geometry with pinpoint accuracy. For example, if you're drawing a new line and hover over the midpoint of another line, you might see a small yellow triangle. This tells you that you're exactly at the midpoint, so when you click, you know your sketch will be perfectly aligned. These real-time cues are a huge help for accuracy and efficiency. They reduce the need to constantly zoom in and check because SolidWorks is already giving you precise alignment feedback as you work. Let's move on to the next part of sketch feedback: symbols for relations. In SolidWorks, when you apply a geometric relation to a sketch entity, like parallel, perpendicular, coincident, tangent, or equal, a small icon will appear right next to that entity in the graphics area. These icons are a quick visual confirmation of what constraints are active without having to search through menus. One of the most useful features is that you can hover your mouse over these icons to highlight all the entities involved in that relation. For example, if you see a parallel relation icon, hovering over it will show you exactly which two lines are constrained to be parallel. This instant feedback is very helpful because it lets you quickly confirm that the correct relations have been applied. And if you spot something wrong, maybe a line has a relation you didn't intend, you can easily select the icon and modify or delete that relation on the spot. In short, relation symbols act as small but powerful visual checks, keeping your sketch intent clear and helping you maintain accuracy as you work. Next in our sketch feedback tools is color coding for sketch status, one of the most useful ways to instantly know the health of your sketch. SolidWorks uses colors to visually indicate whether your sketch is fully defined, underdefined, or overdefined. Blue means your sketch is underdefined. Some dimensions or geometric relations are still missing. This means the size, position, or orientation of certain entities can still change unintentionally. The black means the sketch is fully defined. Every line, arc, or point has a fixed size, position, and orientation. This is your goal for most sketches, as it ensures stability when you move to 3D features. Red or yellow indicates the sketch is overdefined or has conflicting constraints. This usually happens when too many dimensions or relations are applied, and they contradict each other. In this case, SolidWorks highlights the affected geometry so you can find and fix the problem. This color feedback is immediate and dynamic. As soon as you add or remove a dimension, the color will update, letting you see in real time whether your sketch definition is improving or if an error has been introduced. Next in our sketch feedback tools is cursor feedback. This is all about the information SolidWorks gives you right at your mouse pointer while you're sketching. The cursor changes depending on the tool or action you're using. For example, it will show different icons when you're drawing a line, creating a circle, adding a dimension, or using the trim tool. This way, you always know exactly which command is active without having to glance away from your work area. But it's even smarter when you're hovering over geometry. If you bring your cursor close to a snap point, such as a midpoint, endpoint, or center, SolidWorks changes the cursor icon to indicate the potential relation you can create, like coincident, tangent, or concentric. This preview happens before you even click, which makes it much easier to align and connect your sketch entities accurately on the first try. This feature keeps your attention on the sketch itself, allowing you to work faster while still maintaining precision. Finally, let's look at on-screen prompts. In SolidWorks, the status bar at the bottom of your screen is more useful than you might think. It continuously gives you hints or instructions for the command you're currently using, so you're never left guessing about the next step. More importantly, it also shows your sketch definition status in real time. For example, if all your sketch entities are fully constrained with fixed positions, sizes, and orientations, the status bar will show fully defined, and all geometry will appear black. If something is still missing, like a dimension or a relation, you'll see underdefined in the status bar, and the affected geometry will be blue. And if you've added too many or conflicting constraints, it will show overdefined, highlighting the problem geometry in red so you can quickly fix it. This constant feedback keeps you aware of your sketch's health, helping you spot issues early and avoid headaches later when you move on to 3D features. Now let's talk about design intent, one of the most important concepts in SolidWorks. Design intent has been thoroughly explained in the previous chapter, so let's just briefly recap before we move on. Design intent is all about creating a model that behaves predictably and intelligently when changes are made. This means if you update one feature, the rest of the design adjusts automatically without breaking. Two of the most powerful tools for capturing design intent are dimensions and sketch relations. Dimensions give you exact numerical control over your sketch. You decide the size, distance, and angles of features. Sketch relations give you behavioral control, telling SolidWorks how different entities should behave relative to each other. For example, staying parallel, equal in length, or symmetric. When you combine dimensions and relations, you create a parametric model that can adapt to changes while staying fully defined. For example, imagine a rectangle centered on the origin. First, you can add an equal relation so its width and height are always the same. Second, you add horizontal and vertical relations to lock the sides in place. Third, you can use a symmetric relation to keep it centered on the origin. And finally, you only need to set one dimension for the width, and the height will automatically adjust to match. This is the essence of design intent, building a smart sketch that updates predictably without extra work. This animation is demonstrating the process of combining sketch relations with dimensions in SolidWorks to fully define a sketch, an important step in capturing design intent. We start with a simple rectangle drawn on the front plane. At this stage, it's blue, meaning it is underdefined. Its size and position aren't fully fixed. First, we apply sketch relations such as horizontal and vertical constraints. These control how the lines behave in relation to each other, locking in orientation and shape. Next, we use the Smart Dimension tool to assign exact numerical values for the rectangle's length and height. This gives us precise size control. Once we've applied enough constraints and dimensions, the rectangle turns black, indicating it is fully defined. Its size, position, and geometry are completely controlled by our design intent. This approach ensures that if we change a dimension later, the sketch updates predictably without breaking, saving time and preventing errors in the 3D model. Let's take a moment to watch this animation that demonstrates how to create a sketch from scratch, step by step. As we wrap up this chapter, let's talk about best practices for building strong sketches in SolidWorks. A good sketch is the foundation of any solid model, so putting in the effort to make it stable, flexible, and easy to modify will save you time and headaches later in the design process. First, it's important to start your sketches fully defined using a combination of dimensions and geometric relations. This ensures that every line, arc, and point has a fixed position, size, and orientation, making your model predictable and robust. Keep your sketches simple. Instead of trying to create one overly complex sketch, break your design into multiple smaller sketches and features. This not only improves clarity but also makes modifications easier to manage. Always use the origin as a reference whenever possible. Anchoring your geometry to the origin provides symmetry, stability, and consistency, especially for designs that require balanced or mirrored features. Apply geometric relations logically to preserve your design intent. Avoid adding constraints randomly as they might cause conflicts later. Speaking of which, try to avoid overdefining sketches, since conflicting constraints can cause errors and disrupt your workflow. Finally, keep your geometry clean by trimming away unused lines, avoiding redundant entities, and maintaining a neat layout. A clean, organized sketch not only looks professional but also makes it much easier to make adjustments in future design iterations. With these best practices in mind, you'll be able to create sketches that are not only accurate and stable but also adaptable to any design changes that come your way.